Hello everyone, in our previous video we talked about pulse width modulation on PIC32. We've looked at the datasheet and specifics for the PWM module on PIC32. We programmed our chip and by using the LEDs we observed the effect of our modulation. In our today's project we will send PWM signal through our transistor to control the DC motor. We have our protective diode and that is all connected to 5-volt power supply. We will use 4 channels output from our PIC32 and that will be probe on the gate of our transistor. You can use 120 ohm resistor, but I will be connecting it straight to the gate of the transistor, bypassing the 120 ohm resistor. Let's start by going to the files of our previous project. I'm going to right click on it and then I will copy this whole project to a new one, and then let's just change the name to consecutive number or whatever you prefer, and let's click copy. Let's wait for the project to be copied. Now let's set this one as our main one. Okay, once that is done, let's go and start our harmony configurator. Once the configurator has loaded, let's go to MHC tools and open some more tabs. The first one is going to be our pin configuration. I'm going to click on the tabs and just verify that the pins that we used on our previous project are still active. We might adjust them a bit later, but for now that is good. Next tab to open is the clock configuration. Let's add that tab to our menu. Let's go to our clock settings and scroll to the right. Now for our peripherals, let's go to the settings and in the configuration, let's make sure that we have full 48 MHz clock going into TCC0, TCC1 modules. And once you're happy that there is 48 MHz, we can go to the next step. Let's go to the datasheet for our PIC microcontroller, section 34 for our module. Let's expand that and let's go to the 34.4, and in that subsections we will be interested in the normal pulse width modulation, which is the single slope PWM operation. You can find all the details in this section, what we will be performing in our project. In here we can see the calculations, the formula for the resolutions, and as well as the calculation for the frequency. We can calculate that frequency for the signal slope out of this equation. Let's go back to the configurator. Let's change the prescaler and change the period value to achieve the 20 kHz frequency. Let's go to channels 0, 1, 2, 3 and let's change the duty value to the respective values as you see on the screen. Now let's send the code. Let's generate the code for our program. Okay, once that's done, let's hit and program our PIC. Let's wait for all the details to be sent to our chip and let's wait for the confirmation that it's been programmed correctly. PIC programmed correctly. Let's talk about a hardware that we'll be using. So I have a DC motor that I'll be using from my mechatronic board. There is a diode already on this board and the leads connected to that piece of the breadboard. There is a reflective strip fixed to one of the fan blades that will help us to read the speed of the motor. This is our N-channel MOSFET transistor. It is important to mention that this is the logic level transistor. I will place it into the respective place on the breadboard with the resistors already in place. This is a green jump wire that will help us to probe the respective pins on our chip. The voltmeter will be reading the voltage that is currently supplied to the motor. I have a 5 volts power supply which I'm plugging in to the breadboard to be available for the motor and the project. Okay, let's have a look at the close-up of our pins. As we said, the green jump wire will help us to probe the pins PA4, PA5, PA10 and PA11 for the channels 0, 1, 2, 3. Now I've done a little calculations of the frequency just to confirm. I will connect now the gate of the transistor into the channel 0, which is PA4 pin of our PIC. Now we can see the fan is spinning. We have our voltage. I'll be using this calibrated tachometer to check the speed of the fan. All the values, the voltage and the speed of the motor, I will record on a piece of paper to compare later. Now I'm moving on to the next channel, and again the process is the same, taking the speed and the voltage. Let's move on to the other channels, and now let's read the speed and the voltage, and then we have the last channel. Okay, we've got all the details. We can see how the speed and voltage changes with the modulation. Let's go back to our code, and I would like to show you one way that you can adjust the values instead of going to the configurator and sending the code. Let's highlight this command, and let's go to definition file, which will be highlighted there as a tab. Now let's scroll up, and in here you can see all the settings for our PWM initialization. We see all the settings for our channels. Let's take a look, and the second part of this project we will change the values for the respective channels in the actual file, omitting the memory, the harmony configurator. So let's change the values to a little bit smaller with modulation. Let's use those values, but now remember that we are modifying this file. We send in the details to the PIC, but they're not going to be updated in a harmony configurator, so this will be sometimes a little bit confusing. Okay, I have adjusted my piece of paper to reflect the new measurements, and I'm going to proceed with taking the details as expected. The smaller width of the modulation, the slower the speed of the motor, to the point where the voltage actually is not moving the motor at all. We can see what the voltage is, and it's not passing the minimum threshold for the motor to actually activate. So these are all the details for the project. Just to summarize our projects, we observed that the PWM creates the average voltage between the on state, which is the amplitude. The on state we call the pulse width or the duty cycle, and obviously the off state, which is the zero voltage. That is the, between them, it's the average voltage on the output. Thank you very much for watching, and I hope to see you next time in our new episodes and the new videos regarding the PIC32 modules. Thank you. Bye.